Hello, everybody, and welcome to another episode of Quack and Code. And today we're gonna discuss geodata. It's all about geodata. It's gonna be really fun because I have basically an expert with me, which knows a lot about geodata. He even has a YouTube channel. We'll come to that later. And so, Matt, welcome. You're already there, I believe.
Yeah. Hey,
How are you doing? So,
I'm good. I'm good. Yeah, happy to be here. And I think DuckDB is just so exciting for geospatial, and I've just been using it more and more. So I'm excited to kind of share some of this fun stuff I've been up to, and yeah, talk more about geospatial. So
yeah, that's great. So, I'm a bit a newbie around geospatial data, and I want a bit to, I think, to take the session into two times where we dive a bit into your background, dive into the basic of geospatial data for people that are completely newbie in that, and maybe a bit highlight some point for some expert because I guess there is people more interesting, familiar with geometrics data and so on, and then dive into a practical example. How does that sound?
that's perfect. Yep.
Good. So yeah, tell us a bit more about your background and how did you get into geodata?
Yeah. Well, it's kind of logical. I went to school and got a degree in geography, which sort of makes sense. That's kind of how I ended up doing it. But I didn't have any of like the programming or technical background. A geography program, has a few different components. Sometimes there's human geography and physical geography, kind of like geology and all these different things. But you're always studying something about the Earth. And then there's, kind of the practice of, what's called sometimes GIS or geographic information systems, or, spatial analytics is kind of where I think things are going now, but we'll talk more about that. Uses geospatial data to kind of test these different, hypotheses or understand something about the world. So, that's where are people moving, where are people living, how are, different trends taking place on the Earth, be it climate change or transportation or anything like that. So, I honestly, my programming background was pretty limited. I left school with basically knowing ActionScript, which became very defunct very
Wow.
quickly. Yeah. So, I kind of found myself having to learn and pick things up. And so I was just kind of teaching myself as I went along. And lo and behold, I found and met some folks at Cardo, Javier, who was the founder, and kind of just started working with them. And they were building a lot of things on PostGIS, which is the spatial extension to Postgres. So that's kind of where I got into the SQL side, and then I started learning those tools, building applications, learning some different things over there, some of the data science side. So it's kind of just picking it up by default, but I had that background in kind of knowing, okay, here's what I want to understand from a from a geography or from the thing I want to study, and then here's I need to get the data to that place, and that's usually how I would apply these different tools. So that's always where I've been interested in, is kind of how can you apply different tools to get that outcome to find something more in depth, scale to more data, whatever that might be. It can kind of use that. And DuckDB, even just within the past year, I think we're pretty close to when the spatial extension became a core part of the DuckDB release. Is like one of those big things. So I've just kind of picked those things up as I've gone through my career. And then I started talking more about them probably 2021, just kind of posting
Mhm.
things. And apparently there's a lot of people interested in that, which is cool. So I've just been continuing to do that over time.
It's a niche topic, right? Especially like your YouTube channel is mostly about this, right?
Yeah. So I tend to focus on that. It's sort of the what I know. I mean, we bring in a lot of elements from the modern data stack or from cloud or local. I mean, so there's a whole kind of other world of anything that's kind of data analytics. There's spatial analytics. If you think of data engineering, there's geospatial data engineering, and there's funky data types, both in vector data, which is what we would call a geometry, which is what we'll talk about today, but things like imagery are actually stored in like a TIFF file. So you have to analyze these images and then turn them into different things. So there's this whole kind of other piece of how to do that. And especially when the volume of data has just been increasing, like just as it has anywhere else, you need some different ways to do that. And the traditional world is kind of, you have like servers and on-prem, and they can kind of only do so much. And then there's kind of been a shift to some of these cloud tools that will kind of scale, but of course there's sort of a level of expense to them. So a lot of people work to find these different pockets of compute where they can. Like Google Earth Engine is a really good example of that, where they allow you to do that for the most part for the academic community for free. And then what I think what's really compelling about what DuckDB and MotherDuck are up to is to say, you can really take advantage of what's already on a computer, or when you need to scale it, you can go elsewhere too. So, it is super niche, like, it's, kind of this other piece, but it's accessible to anyone too. Like the geometry is just another data type, like, varchar and float, and then you have geometry, and that's, it's just there. It's what you do with that that's a little different than most. So.
Yeah, and I think you mentioned something like there is basically specific data format. You mentioned diff, which is so shapefile. That's what we call it. I'm a completely noob, so you have to educate me on this session, right?
Yeah.
So we have Go ahead.
Yeah, so you have there's this library called GDAL, which is like the Rosetta Stone of like geospatial data types, and I think there's almost 200 different individual file formats that you can store vector and raster data in, each with their different advantages. Some of them are like hyper specific to like something someone developed in like one country. There's like a Norwegian specific file type. There's just so many different things. So I think ultimately that's one difficult part, and there's some file types that are easier to work with than others. So since we're talking about vector today, I'll stick to that. That's kind of, we're talking about points, lines, and polygons effectively that you store in that geometry. So a point is a, infinitely small exact location on the surface of the earth. A line is one or more points connected in an order. And then a polygon is that in a ring or multiple rings that compose of a space. So if you think of like a polygon could be like a zip code or a circle around an area and things like that. So there's all these file types, and what's great about the spatial extension within DuckDB is that it basically ports those same readers in to one single function called stread. So I can have my files, I can read there's a lot of the ones that are mostly the most currently used or most popular, you can read in there. And then I think the big thing that's happening right now is pushing towards like more modern file formats. So GeoParquet is kind of a big thing that's been pushing on, which is adding geospatial support to the Parquet file type system, which makes things a lot smaller to store and faster to read. So
yeah, cool. So when that was one of my questions. I mean, I already have a lot of questions. First, you mentioned GeoParquet. Is it like when this kind of a standard is popping up, or is still really early? How do you see that trends coming in?
I mean, it's still early, early-ish. There's two kind of parallel things happening, which is GeoParquet and then GeoArrow, which is an arrow specification for geospatial data. And there's a really kind of growing ecosystem around those tools. So GeoParquet just had its 1.0 release, I think, in the fall. So it was in a kind of pre-release candidate as of last year, and I think into 2022. But it's active now. More and more people are using it. There's different data repositories that are building off of this. Source Cooperative is probably the most notable one. Chris Holmes, who's from there's a governing body of geospatial data called the Open Geospatial Consortium. So he's leading the research around that within the OGC. And he's put up Source Cooperative, which is sort of like this open data platform for these pretty large data sets that you really, in older formats, you couldn't just store and download. But since you can do things like partitioning and, even spatial partitions, grouping them by clusters of data, it makes it so much easier to access them, and they're just hosted online. So, there's a couple great tutorials he's published about grabbing some data from Source Cooperative, and these are like open data sets of like every building in the world, or every point of interest, or stuff like that. So you can actually just download those, or not even download, just read them as the file URLs into something like DuckDB, and then just start writing your analysis around that. So it makes it super effective to do that.
You mentioned like open data sets. What is the common repository today, like you go to for geodata, and what is the reference, and do you see growing?
Yeah, the governments publish a lot of data. So like, the US Census publishes their own data, and every time they release a census, there's a lot of private companies that publish their own data. And then, more and more you see like the Googles and the Microsofts of the world. Anyone's kind of building like an underlying base map, Apple Maps, Google, there's a couple other companies doing this. They're all kind of behind the scenes contributing to a project called OpenStreetMap, which is you can go to openstreetmap.org. It's been around for many years. It's kind of like Wikipedia for maps. So if I go in and draw a little boundary and like call it my house and add some attribute data, that's now in the database. So it's very easy to actually go and get anything that's on that base map as data. And once again, DuckDB has functions to read in OSM sort of base files, which makes it super effective to grab that data and just start using it. So there's data sets like that, and Overture Maps is another really interesting one that's hosted on Source Cooperative. So there's a ton happening in that space right now. The governments keep adding more and more data. And then on the flip side, you have all this satellite imagery, which is a whole other thing to unpack. I won't have time to do today, but yeah, I mean, there's data everywhere. I mean, if you think of it, there's probably something like, I was looking for wildfire risk indices, and there's a satellite that publishes this every single day that the EU and multiple governments pay for, that says here's the wildfire risk, and you just have to go get it. And once you do, you can make really great use of it.
Yeah, so the OpenStreetMap is definitely something I've worked in the past, but I think like it's always a bit hard to treat the source data. Like can we roll back a bit, like before DuckDB, and like you made a presentation with a nice slide I'm stealing with the modern G stack. Can we go to that one? Let me share my screen.
Yeah.
So this one basically, which is can you work a bit through based on what we discussed so far, and the point I think you mentioned that PostGIS, which is an extension for Postgres, right, is still heavily at the center. So I'm curious to hear like how, just a bit of the history for people not familiar. How come it's still at the center, and how do you see it evolving in the future?
Yeah, I think where PostGIS is really central is that it has the most spatial functionality in terms of the functions. And if you look in the function definitions, any function that leads with st, it's a spatial type. It's just kind of the common, the way you call that. Different databases will support varying amounts of those between even the data warehouses and things like that. But PostGIS has thousands of them. And I mean, there's one to do kind of everything you need. There's center of mass, there's, you can create one that's like the least accessible point in any given polygon. And then there's even extensions on top of PostGIS. We'll talk about one today, but there's, like PG routing, which is a routing engine to, kind of do what you would in Google Maps to draw here's where I would drive to, but you can do it on any network. So what we'll do today is pull in just bike routes and kind of, rate those. So there's all these different things you can do with that. So it'd be just with the sheer amount of spatial functionality. And then on top of that, the support for projections. So of course, the Earth is not flat. So you have to, basically have some mathematical calculation to turn that data into a flat surface, and there's hundreds of these different projections for various means. You can use them to preserve different attributes, but there's a few common ones that are used, and it specifically relates to things like measurements. If you want to measure it, you want it to be in meters. Some show up in decimal degrees and stuff like that. So if you've ever, if you look at Google Maps, like things look weird and out of shape, like Greenland looks like this massive thing. That's just because of the projection that they chose and
Yeah.
like some of the engineering choices they made. But there's the actual world, of course, looks different in scale, but the measurements are preserved in something like that. So that's why PostGIS kind of remains this core, but it has so much other connectivity into different places. Like it's easy to read in files, both vector and raster, into a PostGIS database, and then you can you can do a lot of things there. But of course, the big one is kind of like when you need to go scale, right? And you have either larger data volumes in terms of number of rows or things like that, and then you have to start to kind of explore, okay, what else can we do here? And I think there's this interesting crosswalk where DuckDB can kind of provide that OLAP functionality that can help you go to larger volumes. And one of the specific challenges I see a lot is like where there's maybe some spatial data where it's not necessarily large. Like what we'll look at today is like the New York City citibike system. There's about 1,700 stations. There's more in the data set because they use temporary locations sometimes, but that's not by any means large data. That's 1,700 points, nothing big. But there's millions and millions of trip records that you want to be able to interact with that. So you don't necessarily need a transactional database to be able to query that. You need something else to do that bit, and then you can use the spatial functionality to do other things, like maybe there's spatial clustering you want to do. Maybe you want to create sort of ride territories or grouping or whatever. You can kind of use both tools for what they're really good for. So that's kind of the back and forth between that is kind of how I see these things evolving, which is really good. I think there's a healthy kind of balance between how you can work with all those together.
Yeah, no, that makes total sense. And I mean, Postgres in analytics in general has been there for a long time, and I feel it's for data team, it's always like the first step for analysis. If you build your SaaS business or whatsoever on Postgres, it's like you
Yep.
start querying that and pushing this to some extent, and then when you start to run larger query, you should decouple that and use a proper OLAP system. But then it's basically one use case that fit them all, right? As you mentioned, exactly in data. And so on this image we mentioned GeoParquet, which is kind of the new format. You mentioned a couple of government website which is maintaining geodata, and
Yeah.
yeah.
Yeah, and I mean it's if you're like curious to look around for this stuff, there's like a good chance that your country, your province, your city maintains some sort of geospatial data. Like there's lots of open data out there, and geodata tends to be a pretty predominant one. So there's tons of stuff that's available to play around with. So
And so we mentioned already OpenStreetMap. That's also a big reference, and GDAL, which is the library used, for ingestion and projection, also, I guess.
Mhm. Yeah,
Um,
GDAL allows you to move between file sources. You can move from raster to vector and vice versa. So
okay.
there's a ton you can do, and it's kind of like ubiquitous within the geospatial ecosystem. Like nearly any tool you can find, it's kind of like it's that's what DuckDB uses, that's what
Yeah.
GeoPandas uses, that's what
Gotcha.
PostGIS uses. It's everywhere. You can't
Okay,
live
so
without.
it's kind of like the arrow for geodata. It's like
Yeah,
the man
yeah.
behind
And
everything.
yep. And there's Arrow coming now too, which makes things even
Yeah.
better. Is there's if you can read Arrow, then even better. Yeah.
Yeah, I guess it's because Arrow also has a lot of adoption for communication between data and processing engine and just libraries and interoperability. So one use case, for example, just for people not aware, is that Arrow is easily used within DuckDB to convert a Panda data frame easily. So you can create a Panda data frame or Polars data frame directly from DuckDB thanks to Arrow. So regarding storage, we can talk about it. That's, I think, pretty obvious. I'm a bit more curious about, yes, the visualization part. Can you touch down a bit on those tooling?
Yeah, yeah. There's a few. I just published another update to this as well, so there's a few kind of additions there. But I bucketed it out as there's kind of, when you look at like analytical platforms that allow you to do some orchestration. The company that I work for, Cardo, is one of those where we kind of do a lot of that orchestration on top of like a cloud data warehouse ecosystem. So you can kind of do all that and then easily pass that into visualization. So that allows you to create, map visualizations with lots and lots of data. And it's that's one piece there. There's also other tools. Whereabouts is a company that's built on top of Apache Sedona. So that's kind of it's like the spatial, it's like Spatial Spark, if you kind of think of it that way.
Oh, okay.
So it allows you to do that, and of course it requires Spark and all those different things, but it kind of has those pieces, and there's some visualization built into that. What I think is really interesting is kind of there's a few things that are coming out right now that are kind of being built. Just in terms of like creating maps, there's a cool technology called Felt, which like allows you, it's kind of like it feels like Notion for maps. It's very easy to like collaborate and visualize and do some stuff like that. And then another company that I think it's like a couple weeks old, but it's called Fuse, that allows you to build like these little function building blocks called UDFs within Python code, which you could easily wrap DuckDB in Python, and then kind of scales that from a serverless perspective, but also how it allows you to scale the visualization. And then there's a really amazing library if you're a Python user called Lonboard, Lonboard. It's built by a company called Development Seed, and that allows you to basically take and visualize data, but it does it all with GeoArrow. So it does it within that arrow transfer protocol, and you can visualize millions and millions of records right in your notebook just with a few lines of code. So that's an amazing process, and I think there's this interesting interplay between GeoParquet, manipulating your data with DuckDB, passing that out in a data frame, and then really writing that out right up into a map. You can do that in just a few steps now, which before this took so much effort to just go from data to map, and without getting into the weeds of how the map visualization technology works. It used to be really tricky to do. You have to generate these static map tiles, as they're called, and you would have to have either some library or some server to do that. Now it's just file, manipulate your data, map, and I think that's like the really cool part. So yeah, you're showing Lonboard right now, which is like just if you want to get started showing a bunch of data, that's a cool place to start.
Just wait. I'm really sorry, but we had the crash, and I'm not sure. I think we're back.
Okay.
That's fine. It's just a small lag. No, but that's great. And yeah, so this longboard thing is over here. So what I suggest is that we are already at halftime, so we can go to the code source that you shared with me. I
Yep.
need to find it actually back. Wait a minute. And we're gonna just go over that, so you can go for the people following along. Can you still see my screen? Because I have
Yep.
some weird hiccup, but let's hope it's running. So yeah, we have basically this repository. You can go for. I'll put the link also in the description. And basically we're gonna go to a couple of examples that just SQL file and DuckDB CLI, I guess.
Yeah. So what I'm doing is, basically building off of your many tutorials, kind of just going DuckDB in VS Code, and then writing and interacting with data. But we'll interact both with MotherDuck and then also with PostGIS. So I have that part of the code. Is there's a few extra steps there, but I can cover that. It's to talk about what you would need to do to get there, but just to actually do some routing. So yeah, do you want me to share my screen or?
Yeah, I think we do have an issue with the live stream because I do receive some comments. So let me check this out. 1 minute. All right, we are back, hopefully. Sorry for that. So we were just about diving into the code. So what we're gonna do basically here is just go over the code which is on GitHub, and we're gonna follow a couple of example in geodata. Let me just fix this quickly. There we go.
So
we're back.
Oh,
yeah. So sorry for that. So we we're gonna just run the CLI, I guess, here, and as you mentioned, you're following the same setup than me, where basically I'm sending queries to the terminal, right? And so it's nice because that's enable you to go into a single SQL file, right? And we are using VS Code here, and so I can just send this and send it to my terminal over here. I want to try something, so I'm relaunching DuckDB because I think there is a couple of load which is not needed anymore, because there is automated hook internally from DuckDB, which is detecting and installing and loading an extension directly for you. So yeah, you want to talk maybe quickly about those two, why those two are needed?
Yeah, so when you load in the spatial extension, that basically allows you access to all those ST functions that I was mentioning, as well as some of the special ones to kind of read in that data. So you have that ST read function. So if you go to the documentation, you have that function, those libraries now, and that allows you to basically access that geometry data type. So I can both convert geometries from different types, if there's text or binary or GeoJSON, which are different formats to form that. And then you can create geometries from values. Like a really common one is ST point, which basically allows you to take a latitude and longitude and turn that into an actual point, right? So that's one you can do there. So let's say you have a point and then you want to say, okay, I want to make that a buffer. So show me, turn that into a circle with, 100 meters around it. Then you use ST buffer to do that. So it takes the geometry as an argument and then the radius that you want to create around that. So there's lots and lots of functions that you can see. You can do these different things. Like I can measure if there's a polygon in an area, or I can peel off the lat long, columns from that and things like that. So this gives you access to all of these. And then the special functions that are within DuckDB is this ST read. So that, makes it so I can just read that raw, file that's on my, on my computer, to just read that as a table, so be that in your Python, be it in a CLI, wherever you want to work with, and it supports all these different file types. So I mentioned there's a lot of these different types of files. This is just a sample of the things that you can use, right? And then the OSM data is you can actually pull down these files. They're called .osm.pbf, and those are just big batches of OpenStreetMap data. And there's a few other really cool tools that people are building around this. There's a nice library called quack OSM, and you can actually pull down and read some data there, just using, there's a lot of filtering. There's so many tags within this. Like if you think about it, there's, it's kind of like the node and ID, a geometry, and things like that. And then there's tags, which could be basically hundreds of different types of like nested JSON, which is kind of crazy. But QuackOSM kind of helps you filter that to say, okay, I really only care about roads, or maybe roads that bikes are safe on, and things like that. So that's what
you mentioned conversion. I just wanted to highlight, like, from the DuckDB extension, that you have multiple ways to do conversion from other format. That's what you were mentioning, right? Because there is multiple of them. And so if we go back to the code, we have, so we mentioned also you can do all those commands. Of course, you can, you don't need to use the DuckDB CLI. You can use just the notebook and the Python client and run this into a notebook. So we have the Spatial extension, HTTPS for connecting. This also is not needed anymore. I think it's because before we did it specific the region, but I suspect, let's try actually, it's gonna work without. So you see, so I think it's detecting the region now automatically based on the URL. So we have quite some data here. So more than 3 million row, right? And so can you talk to us a bit to those Parquet data sets?
Yeah, so those are all coming from Source Cooperative, which is, it's called beta.source.coop. And this is basically that really massive data set that I mentioned, that's looking at, it's like a combination of your Google and Microsoft Open Buildings data sets. So basically, Microsoft trained this supercomputer to go out and detect building polygons from satellite imagery, and then they just publish that. So there's like 2 billion footprints, nationwide, but this is all put into GeoParquet that allows you to, do things like this and query it at scale really, really quickly, and go from there. So it allows you to scale that up quite a bit to go, and actually use that. And then Source Cooperative basically gives you access to the partitioned, data. So it partitions it by, usually by country, or this indexing method called S2. And there's a few different ones of that, so that it's actually like a spatial partition, more or less. So you can actually just, I only care about Norway in this case. I can just grab Norway and then be on my way. So it allows you to do that really much more effectively.
Cool. So so here we can describe the schema. So it's just to describe, and then the URL from S3. So this is a public bucket, so I don't need to do anything. And so we see we have geometry blob and different things, like country ISO. What's the confidence?
That is basically the confidence in terms of that thing, existing as a actual building. So of course, you're training basically these, like, almost like a deep learning model to detect that as, this is a building. So it gives you some level of confidence. Like, we think this is definitely building, or maybe not. So.
So I see. So let's go for it and create that table. And I'm wondering, so I haven't loaded the Spatial extension. So I think there might be a hook here, or I might get an error based on that. So let's run. I want to check it. Okay, so here I have actually a specific warning, which is nice. So my point was that when I'm doing a query on a various tree, it's actually using the HTTPS extension behind the scene, and I don't need to install and load those because there is specific hook. But for this, as you see, is detecting that I'm calling a function which is part of the Spatial extension. So I'm just gonna install it and load, and just create again this. So what are we doing with this? We're taking just the data from Oslo. Is that it?
Yeah. So what we're doing is we're creating, like basically finding around a centroid in Oslo. So I'm creating a table because after that, I'm going to basically export that out as GeoJSON. And then once we
Yeah.
swap over, I can actually show you there's a really nice extension in VS Code to just make a map really quickly. So I just can select my GeoJSON and throw it in a map. So as you can see here, I'm using this function stgeom from WKB. And
Yeah.
what that's reading, it's reading the well-known binary, which is the how GeoParquet represents the geometry, and then turning that into a
Okay.
geometry that DuckDB can interpret. And then I'm reading that directly from that file type. And then the last bit is you can see there's a where clause, which is this std within. So that
Yeah.
basically represents st distance within. And what I'm doing, it's kind of funky because the projection, it's in a decimal degrees, so it looked like this oblong oval, which is odd, but
Yeah.
it's just a simple way to filter it. So what I'm doing is you provide it three arguments. First is the geometry that you want to filter. This is from the table. The other one is why you want to measure it from, which is this point is a lat long representation of approximately the centroid of Oslo, and then 0.1 is basically the distance that I want to measure from, and that's in decimal degrees. So it's not perfect, but it gives us a nice way to just kind of grab a chunk of data to see, and then we can do that. So
Okay.
it allows you to just query it there, and then so you can select that, and then you have a table of, I think it's like 50 some thousand buildings, within Oslo.
Just a question. How do you differentiate a parquet from a standard GeoParquet? Just by the data type, which is inside
Yeah,
it?
just the geometry. You'll have that geometry and well-known binary, and that's pretty
Okay.
much it. And
Okay.
then there's optimizations made on that column, for indexing and things like that.
Great. So now we have our table, which is created in memory DuckDB, because I haven't passed anything when launching DuckDB. So everything is still in memory. So if I quit, everything is gone. And so now you want to copy to GeoJSON, right?
Mm-hmm. Yeah.
What kind of format is used usually GeoJSON? Can you walk us through that?
GeoJSON can be used just as any other standard JSON. I think for a while it was the web standard, to actually kind of either put that on top of a map. So there's libraries you can just put that on top of a map.
Yeah.
And then it also allows you to, it's fairly effective to share and store. So if you loaded that into GitHub per se, it would actually just, if you clicked on the file, you could actually see a little map that pops up. So it
Yeah.
knows that it's GeoJSON and creates a little map there. What
Okay.
what you can do is that within VS Code, there's an extension called, let me get the exact name because I always forget the exact name of it. But let me go by my
I see
ID here.
GeoJSON snippet, GeoJSON viewer.
It's called actually, I think it's called Geodata Viewer.
I see it.
So it has
I have it. Yeah.
150K.
I have it already. So I
Yep.
guess I need to click here.
Yep. So all you have to do is create the GeoJSON itself.
Yeah.
And then
It's done.
on the left, if you right click on the file that's created, you'll see a little option that says map. And then it will
Yeah.
just create a nice little map for you.
It's done. Yeah. It's done here.
Yeah.
Yeah,
So
that's pretty cool. So that's like really how you can quickly interact, like process data and visualize this. How this
mhm.
like you've been in the domain for a couple of years. How this kind of workflow changed for you compared to before, like pre DuckDB, I would say.
The number one thing that's like making a difference is that, before you always had to like load data somewhere, so either there's like you have to pull the file into a notebook, read it, and that operation could take some time, but if you just wanted to see what's in there or quickly visualize a
I
chunk of
see.
that data, this makes it so much faster just to do that. So I can go from, without really, like loading a data file, like you have to, take the file and put it into your Postgres or do something like that. That kind of like IO operation is like significantly decreased. Plus the ability to do that exploratory work, especially on much larger data sets, is way more efficient. And that's kind of a big chunk of what you do, is to say you have these much larger data sets and you just want to do some joins or aggregates or, like search by time or whatever. That's been significantly decreased. So your time from, file to exploration to, some sort of analysis goes much faster. And then on top of all of this, I can actually just, once my data is processed, I might get rid of some of it or, aggregate it or something. And I can push it if I need to go somewhere else with it. It's quite easy to take it there because I can spit out Parquet files, and if I need to partition them, I can do that. And if it's something I'm doing all the time, DBT's right there. So there's this whole little ecosystem that's growing quite a
Yeah.
bit to just make that. So I'm using it multiple. I'm using it, if not every day, every week, to just see what's going on, and then I figure out, is this good data? Do I need to clean it? Do I need to throw it away? What do I do? And that little bit is a big time saver.
Yeah, no, and I can really relate it also in the analytic or data engineer workflow, where you have a couple of files that you want to explore that you have to process, and you grab a file from S3, and it's just quickly, as we saw, we can describe just the schema with just one line, right, without
Mhm.
any
Yeah.
different dependencies in the CLI. So I'm using this actually all the time, and I would recommend, like, it's not because like it's a DuckDB team session, but any data engineer that's like, even if you're not actively using DuckDB, it's just a toolkit for quick exploration. That's pretty handy. So
Yeah.
that's cool. So we just did a GeoJSON based on spatial data, did a quick filtering, and
Mhm.
display it on VS Code. So that was the first one. We
Yeah.
can maybe try this one. I haven't done any. Maybe I can.
I
Reopen
I have the
this.
second one that is in the folder 2024 0327. I have it on my machine, so I can run that because
Okay.
there's a few other dependencies I can walk through if that helps.
Yeah. Let's do that. Uh, so let me uh,
So I'm sharing the screen. I don't know if that's coming through or not.
yeah, it's not coming through. I think. Let me double check. But so in the meantime, maybe you can walk us. So it is this one you mentioned that you were saying there is extra dependencies.
Yeah, yeah,
Yeah,
0327.
yeah.
So what I
What's
did there,
the other dependencies? Just for my understanding.
yeah, so I loaded a bunch of data into MotherDuck, to actually, because it was really kind of longer form. So
Mm-hmm.
it's nearly 100-ish million rows. So I just wanted that, like, it just gives that big boost for like that serverless side. When you want to do
Yeah.
some of those things really quickly. So the data that's here is from the citibikes dataset, which is the bike share system in New York City. So like I kind of mentioned it earlier, is that there's 2,300 stations, both current and historical,
Mm-hmm.
that have existed at some period in time. And for every trip that's taken, there's basically a log of that in this open data. So it has all these files, and of course it's not clean data. They switched schemas twice, which is um,
That's I think that's one big problem with the open source
yeah,
the I mean the open data part, sorry, from
yeah,
government, is that I think they still need education and if evolving around those things. I mean, if they move already from Excel file to CSV or Parquet, that's already a great win. I think like
yeah.
New York's data has been moving, to Parquet file a couple of years back, but there's still a lot like
Yeah.
it's just Excel sheet. And I think like, yeah, asking for stability in schema is, I think, another level
Hmm.
of maturity that's it's not there yet. Yeah.
Yeah, yeah. It's weird because I think it's shifted providers a few times. Like now Lyft owns the system,
Okay.
so I think they're doing some of that. And then in the past, so there was one schema switch around 2015 or 16. The system
Yeah.
launched in 2013, and then in 2021 there's another switch because they added new bike types, like a category. Because there's e-bikes, there's like kind of in between e-bikes, and then there's your regular bike. So you can see that. And there's some data about like if they have information about your gender and stuff like that. If it's a member, like you can have a membership or casual ride. And then the weirdest thing that I found is that there used to be a consistent lat long for every row for this end and start station, but now it actually does it based on where you end it in the app. So sometimes it
Yeah.
will log it to the station, and sometimes it will log like slightly off to like the left or the right. It's very, there's all these intricacies. But what is great is I was able to I couldn't read them directly because they're zipped CSVs and I didn't use the same the right zipping standard, which was another annoying thing. But I pulled all the data down, created a little code snippet, and then just started uploading these the Parquet files to MotherDuck, and then I kind of pulled that into one giant table, which is that that citibike. I think it said citibike 2021 to present. So within that, there's like 98 million rides across the city, which is pretty good. I think that's having that is kind of going there. Let me see.
That's
I don't know if
but if I'll suggest we go to the code through because I have a slightly technical issue to show you screen. It's been a bunky ride today. It's like that, that's show you that it's live stream. There is nothing recorded, but
no,
we'll definitely come back because I think what's nice is that with MotherDuck is that you can share, database. So you could you could share this one, and we can come back with a proper blog for that specific.
I'll get it cleaned up, and what's great about it is like it's effectively doing the same things where I can kind of see, okay, where's the top station. Like and there's this one station for whatever reason at 21st Street and 6th Avenue that's like the consistently always the top. And then you can kind of see, okay, where are all those people going to, and it's like really short neighborhood trips. So for this reason, Chelsea is like the hotspot for city bikes and people riding just in the neighborhood. And then the last little bit was actually kind of attaching a Postgres database. I just finished up a book last year on spatial SQL and doing that in Postgres, but actually working with PG routing. So I'm taking that same OpenStreetMap data and creating a network and prioritizing bike safe routes. And then within that, I can write there's this very long query on like line 62 to actually create the routes for the top 10 locations that station goes to. And I can actually end up and see, here's the routes or the bike safe roads that are most used within that. So you can actually go from this, what I think is great is using all these in conjunction. I can get some actual insights out of there, like where should I prioritize, bike lane investment or bike safety in the city or anything like that, just based off all this data of you have millions of people traveling on bike, day to day. And a lot of this data exists for, bike shares in different cities around the globe. So, it's a very cool data set that you can take and then have some practical something come out of it to say, here's some recommendations you can make if you're going through this data. So it just shows like this really cool, and I'm doing this all within the command line, which is great. I'm connecting to my Postgres over here. I'm connecting to MotherDuck over here. I get all the power that I need between the two. So it's just this really nice union of bringing all those together.
What is missing for you today? Because so you mentioned like the dependency to Postgres. So maybe let's go over the code. So here you're showing the top station, the top neighborhood. So this is just working with the geodata, and then from a specific neighborhood. And so I guess so there is directly a station name, so you don't need geodata for that. It's just the station name. Then here what is this? Explain maybe a bit to the audience.
Which line are you on? Because I'm not seeing it on
extension,
my side.
And now you should see it.
I'm following along. So if you tell me what line you're looking at, I can.
Yeah, for sure. So the install Postgres line.
So what I'm doing there is I basically took that table with the top destinations from that station at West 21st and 6th Avenue. And what's great is I can just attach my Postgres database and then pull that over to write a table from DuckDB, which is derived from data in MotherDuck, and push that into my Postgres. I can create a table or view whatever I want. And then what I'm doing here is writing a query for PG routing to actually draw those routes, right? So I'm saying from that station and to the top, I think I picked the top 10 stations that people ride to there, create those actual routes and using that prioritized bike network that I've created. So you can actually go from like one to many to visualize all of those. And you could go for every single one across the city if you wanted to, and just see that. But what that's really nice is that, like I said, PostGIS has that like heavy, deep spatial capability that,
Mm-hmm.
you may or may not want in an OLAP, right? That there's like, it's kind of choosing the right tool for the right battle. But the fact that I can do all my data prep here and then still connect with really outleaving my IDE in
Yeah.
doing back and forth is really, really nice. And you can just
Yeah. Yeah.
have that little bit over there. So I think that that's like an incredibly like powerful connection. And then I'm just spitting out those routes. I can create a map and see what's there. So, I don't have to, go back and forth from, PG admin here or whatever, whatever you want, it's all in
Yeah.
one
Yeah. Yeah.
place, which is
Yeah. So
great.
that's
Yeah.
yeah. So that the interoperability with Postgres and DuckDB is really nice, and it worked both sides. So we have a lot of people that do their first analytics in DuckDB, so they run the compute in DuckDB from Postgres. So
Yeah.
it's the other way around than here, right?
Yeah.
Where here you federate the query from DuckDB and you push it to Postgres, but you can do the other way around to
Mhm.
offload analytical workload to DuckDB. And
Yeah.
as you mentioned, yeah, no context switch without different CLI. You do everything here and talk to your Postgres. I want to come back and maybe because we're already running closing to the end on a bit of closing thoughts. So you mentioned on this use case, so PG routing, which is, another extension to basically for routing functionality. And
Yeah.
so here my question is like, where do you see the DuckDB Spatial extension evolving? Because it seems like there is so much available from Postgres. Um, in my opinion, it seems unreasonable to think that DuckDB can, cover all those things. But where do you see what is the one thing that you're still missing today in DuckDB that you would like to see in geodata world?
Yeah, I think you're spot on in saying that, it is unreasonable to say that it will, get to that parity of PostGIS or anything like that. I think if I have my wish list of things I would love to see, there's GeoParquet. I'm kind of reading in via hack. Like I have to take the binary and then do that ST as WKB that we kind of showed.
Yeah.
So having some of that native support, and now GeoParquet is supporting a geo arrow within that. So being able to go from, file, arrow, DuckDB, kind of streamlining that will definitely kind of add that extra level of things there. And then the last is probably like supporting, like maybe if there's, and I don't know if there's a good way to do this, but projections, because a lot of data is stored in that it's a projection number called 4326. So like that, in the first one, it's a decimal system, right? But it's not meters. And usually you measure things in meters, not decimal degrees, across the earth. So, there's little things like that, can be addressed by other things, but just having like a spatial OLAP, that can scale up in different ways. There's, you have it locally, you can go serverless with MotherDuck, you can go into Python. I think that's just a massive leap forward. And then, there's just those little pieces to kind of, get, connectivity all across the line. But I think it has a lot. And I think one thing I'm also really interested in is the native geometry types. So there's a geometry type data type supported in DuckDB. And then there's another one that's called like point 2D, line 3D.
Yeah.
Those are super fast. And there hasn't been like a lot of work on the data type of geometry for a long time. So it's very exciting to see where that would go. And I'm curious to see how that pushes forward and progresses, in addition to some of the other file things. So that's the two pieces I would say is like, GeoParquet, and then seeing where the native geometry types go.
Yeah. So I don't know if Max is watching this because he's one of the big contributor of the Spatial extension. But you heard the wish list. But to recap, better support for ingestion of modern file like GeoParquet without a small workaround, and then projections. But then at the end, you still see, as we talked earlier on this session, Postgres as a key element for other kind of things like you mentioned routing, for example. Does that make sense? Like as a trend for you?
Yeah. I mean, I think there's, like PostGIS and Postgres are always going to kind of be there in some form, especially for the things that they do well with. But, like I said, I think, having that easy coexistence, like you said, either from DuckDB into Postgres or vice versa, as a DuckDB, foreign data wrapper, that is so, each thing can do what it does really well. Ducks and elephants can be really good friends. So
So Max, just reply if you can see the comment that is in the chat. So
yeah,
I hear you.
good.
Great. Thank you so much. I think we went a bit fast on the second part of the coding, but don't worry, we'll be back with a proper blog post probably. And yeah, I'd like to do a dedicated video on spatial data because I learned a couple of things, and I was pretty amazed like how easy it was, because the last time I checked, like I would say 5 years ago, with trying to do things with leaflet and so on, the process like was much harder, was involving still Postgres and so on. And I think here there is a couple of things that's being streamlined. That's, I think, the conclusion of this session, through thanks to DuckDB and the Spatial extension. So that's great. And the interoperability with Postgres make it really nice to fit directly into that ecosystem. Matt, where can we find you? And probably I should mention your YouTube channel. But what else do you want to promote? That's your pitch time, because you spend a lot
Yeah,
of time with us
perfect.
today.
Yeah, so I'm on YouTube at Matt Forrest. So I post videos regularly there on topics around geospatial, and do some live streams with some different coding webinars. I'm trying to do one like a kind of a weekly thing on different topics, and then the other places on LinkedIn. So just find me. If you go to my YouTube, you can find the link there. And then I post stuff pretty regularly there as well. So you can find me in those places. Like I said, I work for Cardo, so we're doing a lot kind of in the spatial scale and spatial analytics there. And then if you're really interested in this, I got a book here, so if you want to dive deep into spatial SQL, you can check that out, and there's links on my different places on the internet that you can find that too. So
Cool. I'll make sure to share all the links in the description of the YouTube video. But thanks again. For everybody else, we do a Quack and Code session every other week on the Wednesday. And in 2 weeks, I have actually finally someone from the DuckDB team talking about CSV. And I know it's a nightmare for a lot of data engineers. So we're gonna see how DuckDB actually do a lot of things under the hood to make the parsing of CSV a blessing. I'll see you around, and have a good evening. Cheers.